Hey dudes, we are checking out the applications of the unit circle today, just one or two quick tricks. Before we hit that, I wanted to show you this just to clear things up. This is a common question. You see cosine squared of an angle. What that really means is cosine of that angle squared, right? It's a shorthand way of writing it so you don't confuse if you square the 30 or square the whole thing. You take the cosine of 30 and square the whole thing. So I just wanted to show you this piece. If you take the cosine of 30, you get root 3 over 2, which is this decimal. If you take the sine of 30, you get half. If you square both of them, if you square this and square this, you get 0.75 and 0.25. And when you add them up, you get 1, which is because of this. This is saying cosine squared of theta, or cosine of theta squared plus sine of theta squared should be 1. And that makes sense because really cosine is the a value and the sine is the y value. This is just Pythagorean theorem in disguise. A squared plus b squared should equal c squared, right? And since we're on a unit circle, our radius is 1. So I want you to know this piece, that cosine squared theta plus sine squared theta equals 1, and also that when you say cosine squared of an angle, it really means cosine of that angle squared. All right. So here's the whole idea is that they give you the ratio that makes the sine of the angle. So they say sine of an angle is -3 over 4, and they say find some other ratio. So they say sine of some angle is -3 over 4. They give us some contingency about where the angle is. They say it's between pi and 3 pi halves, so we know it's in this quadrant. Fine. We also know that the sine is negative, so it's got to be down here. It's either in this quadrant or this quadrant, and they take away that doubt by giving us some constraints there. Fine. We know we're in there. We know that sine is opposite, the opposite over the hypotenuse, right? So they give us the relationship between the sides. They say the opposite is, I'm going to steal the negative on that and say the opposite is -3, and the hypotenuse is 4. So that kind of makes sense. If you're building this triangle, the opposite angle is -3, and the hypotenuse is 4. Great. We don't even really need to find the angle there. It doesn't really matter. If you build this into a triangle, you have 3, 4. You have to find this other side b. We know that a squared plus b squared, I don't know what that is, should be c squared. C is the hypotenuse, so c should be 4 squared. This becomes, what, 16 and 9 and b squared. And so this becomes, what, 7? So b squared is 7, so b is just root 7. So we know that that's this length. Fine. And then when we try to, they said find the cosine of that angle, or cosine of the angle, we're just talking about the same reference angle. So you can say the cosine of the angle is the adjacent, and in this case the adjacent is the b that we are looking at, so the adjacent over the hypotenuse, right? And the hypotenuse here was 4. Right, so we get root 7 over 4. I think that's what they got. Yeah, there, root 7 over 4. If you'd like to see their non-hand drawn with a mouse way to do it, there you go. There is some stipulation about the plus or minus when you take the root, and that's no problem. They run it a little bit of a different way. They run it with Pythagorean theorem, but you get the same idea. You know that's cosine squared of theta plus sine squared of theta equals 1. This is still Pythagorean theorem in disguise. We know sine squared of theta is 3 squared and 4 squared, so 9 and 16. You subtract that, you take the square root. It's the same thing. I like it this way just because it makes a little more visual sense to me. And then we have to pick one if it's positive or negative. And we say, hey, the cosine is going to be negative because it's going backwards. It's in this quadrant. So cosine is going to be a negative value because it's a negative x. Sweet. Okay, let's try this out again. We'll try it in 2 different ways. We're going to try to find the tangent of x given that cosine of x is -3/4. So the cosine is the opposite, sorry, the adjacent over the hypotenuse. So this should be -3 over the hypotenuse. Now, it could be up here or it could be down here because we know the cosine is negative. They give us some stipulations between pi halves and pi, so it's going to be up in this top quadrant, right? So it'll be this one, like that. So the cosine is -3. This is the adjacent, and this is the hypotenuse. So this should be √7 like we found before, except now it's the sine value. All right, and so for the tangent, if we're trying to find the tangent of theta, tangent is opposite over adjacent. Opposite's going to be this √7, and the adjacent is going to be the -3, and there we go. We've got the exact value. You could also do that with sine squared of x plus cosine squared of x equals 1. And we could put in cosine in for this. This would be -3/4. That's the cosine of x squared, right? That's what this piece means. Here's sine squared of x equals 1. This becomes 9 and 16 equals 1 equals, and that's sine squared of x still, plus that. When you, this is 16/16, and when you subtract 9/16 from there, you get sine squared of x is what, 7/16. And when you take the square root of both sides, the square root and that square cancel out, and you get sine of x. Oh, oops, sine of x is √7/4. And then we'd have to take that value and this cosine value and plug them in for tangent. Oh, this is getting messy. And we just know that tangent is opposite over, sorry, is opposite over adjacent is sine over cosine. So the tangent of that angle should be the sine over the cosine, which is √7. Oh, sorry. √7/4 divided by root. Like that. And when you divide, you invert the second fraction and you multiply. So this becomes 4 over -3. And therefore these cancel out. And you're left with √7 over -3, just like we thought. That's why I like the visual trick, because it's faster. This works too, and it can work a lot faster if there's variables in there. But for the easy stuff, try that. Just build yourself a triangle using opposite and adjacent. Cool, that's it. We'll see you later.